Hi, my name is Clark Brenzel. I'm the weed control specialist with the Ministry of Agriculture. And behind me we have a plot here looking at hard water antagonism to glyphosate and some of the things that we can do to kind of correct some of that hard water antagonism that we find around the countryside. So if we start in with our first couple of plots. So the second plot in is glyphosate applied with hard water. And this hard water was about 1,100 to 1,200 parts per million of calcium carbonate equivalent, largely calcium and magnesium in the solution, and maybe a little bit of sodium in there. And then so on the left, what we've got is that water run through a reverse osmosis machine. And essentially what the reverse osmosis machine does is it takes all the ions out of the water, and so it becomes pretty close to distilled water at that point. So there's maybe a few little ions hanging around in there, but they're not antagonistic anymore. And so essentially this is the real contrast in our plot. This is the worst case scenario and this is the best case scenario essentially. But if you can't afford putting in a reverse osmosis machine, they can be fairly expensive and they can be limited by capacity issues in some ways. I often get the question, well, what about just using our regular water softener and using that softened water? Well, in this case here, we've got this third plot here is using the softened water. And when you have hard water, what happens is you run it through your water softener at home, it substitutes that hard water essentially for salt. And so we did some testing on all three of these waters when we went before we brought them out here to use in the trial. And essentially the sodium in this plot was way, way high. So we're probably looking at antagonism largely from the sodium ions that were in there as well. So that's a concern with just softened water. The next two plots are liquid nitrogen, ammonium sulfate, 210025 to 8-ish, wherever. And essentially these are used often as water treatments. And so in this case, they really haven't performed all that well. The one on the left is the recommendation off of our fact sheet on our internet. And the one on the right is based on rates that were provided by an ammonium sulfate calculator off the Washington State University website. And so what they try and do with that calculator is match their ammonium sulfate use directly to the number of hard water ions that are in the water that they're working with. And so in this case, really neither one of them worked, which was a bit of a concern going into this plot because one of the things that we discovered is that the water has really high sulfate content as well. And so what that means is that it may not allow these things to dissociate properly, reassociate with the hard water ions, and then the ammonium component associate with the glyphosate, and then thereby reduce the antagonism as a result of the hard water. Moving on down to the next plot was intended to be kind of an oopsie in that it's another common liquid fertilizer that's used as an adjuvant, which is UAN, or 2800. And that was put in at 1%. And essentially it really hasn't provided any benefit over the hard water on its own, and that was entirely expected. This was essentially just to illustrate that all liquid fertilizers are not made the same. I also get questions from farmers about using Li 700 to reduce their hard water antagonism, and essentially it's a non-ionic surfactant with a drift retardant in it, and so it really doesn't have much in the way of components that you would expect would be effective in reducing hard water. And so this plot really kind of supports that. Again, we're really not getting much in the way of reversal of that hard water antagonism. Maybe like a smidge, but that's about it. We're really not getting a lot at all. The next plot is another product that's on the market from a third-party company called Omex, and it's called Fix. And essentially Fix is a sulfuric acid or hydrogen sulfate, where one of the hydrogens in the hydrogen sulfate is replaced by a urea molecule. And by doing that, they can formulate it as a granule formulation. And then once it gets dumped into the tank, it reduces the pH, and it also liberates the sulfates that are in the sulfuric acid component. And then that helps alleviate some of the hard water antagonism. And that has actually worked reasonably well in our plots here. But I often hear from farmers, oh, well, that means that if I drop my pH by a really significant amount, that means that'll get rid of my hard water ions. But we also did a plot where we just reduced the pH using hydrochloric acid, which has no sulfates in it and has no other characteristics that would suggest it would help with hard water antagonism. And we can find here that we're really not getting any impact at all from reducing our pH of our herbicide. And essentially, when we look at pH adjusters and adjusting our pH down to an acidic level, there's really no benefit to the herbicide beyond what the herbicide can take that water pH to on its own. Most of the herbicides are weak acids, so that means that when they're formulated with the spray solution, they're going to come in at that pH 4 area. If you drop that down to 2, you're not going to improve the performance of that at all. And really what you may be seeing is that you may be getting a little bit of actually acid burn that's giving people a little bit of a warm feeling in their belly that things are dying quicker than would normally be the case. So that's what we've done here in this plot with hard water. And so I think we also have wheat in this plot that died in every circumstance. So it also demonstrates that we've got difficult to control species like pulse crops like peas, and then we've got very easy to control species like grasses such as the wheat that's in this plot. And so in future, if we do this plot again, what we'll be looking at is probably dropping the rate for the wheat or increasing the rate for the pulse crop. For more information on herbicide antagonism with hard water, contact the Ag Knowledge Center in Moose Jaw at 866-457-2377.